Okay, here we go. Right. Let me know everyone if you can hear me clearly in the chat. Okay, Joshua can, Sat can, yeah, yes, Vishnu can. Okay. All right. So I'm going to proceed with the tutorial as is then. Welcome back, everybody. Congratulations on making through 4 days of really brutal exams. I think one of them is not as brutal, which was like yesterday. COE 692. To me, that was not pretty brutal, but the others are kind of brutal. Um, so for this tutorial, we are going to review the concepts, that came after the midterm in COE 691. So I'm going to get started right away. I will start by showing you what we're gonna cover today. Okay. So in COE 691's final exam section, or final exam study session, we're gonna cover the following things. The first is we're gonna deal with requirements analysis. So that would include like a couple of diagrams that we have seen before. The second we're going to do is requirement specification. The third one is requirements management. And finally, we're going to do some risk management and analysis as well. And in case you don't know, sometimes like my whiteboard will complain, or my whiteboard might not like will not like might not my whiteboard might will not like my whiteboard might not work like 100% correctly, but hopefully this won't disrupt our tutorial. I'm sure it won't. I mean, unless it's like some kind of network interruption. In that case, I will let you know. Or I don't know, maybe Zoom chats will crash as well. So maybe Zoom will crash as well. So who knows? All right. So I'm going to start everything off with dealing with requirements analysis. So I'm gonna scroll down here on the presenting board. Okay. Now, just to let you know, when I write, you will experience a bit of delay as my ink my digital inking will as my digital inking gets sent across the network to the whiteboard. That is pretty much like what lag kind of is. So hopefully that is normal. A bit of latency is expected when you send things like live over to the network. So with that out of the way, um, I also read Jasper's few messages about like a couple of things as well. So yeah. By the way, for this tutorial, I would like to thank Jasper Cruz for making the notes as always. Jasper, if you can hear me, make sure you rest your wrists and exercise them from time to time so that you don't get carpal tunnel syndrome as well. The same goes for the rest of you as well. If you're since we might work with computers a whole lot. Um, like our hands will have like a whole slew of like bad problems. Make sure you exercise your hands from time to time so that you don't suffer um carpal tunnel syndrome or any other bad problems in the future. Okay? Yeah. Oh, and yes, shout out to Joshua for the mock test. That was really helpful. We might cover that if we have the time. We only have 2 hours, so let's see what we can do. So, our first thing we're gonna deal with here is something related to requirements analysis. But why do we do that stuff? We want to describe what the customer wants or requires. Oh, whoops. Another thing we want to do is that this will be like a basis for creating a software design. So when we design our software, everything will be based on what we are doing here. For now, it doesn't have to be a software system. It can also be a hardware system as well. Even sometimes, if you work with hardware, you may have like you may have like different design like different like requirement analyses for dealing with like hardware components and like what you want this hardware to do. So another thing we want to do when we analyze our requirements is to define a set of requirements to be validated once we build the software. So when we build the product, we want to see how it measures up to our stakeholders' requirements. In this case, requirement analysis allows will enable us to know to find out like what is going to be assessed. Okay, so so you can also think of requirements analysis like this. You have originally two worlds. One is one has a system description, which is everything the customer wants in words, for example, and it could be documented during elicitation. In the other world where we pretty much live, we deal with design models. So how do we turn the system description, which basically comes from like requirements documented requirements that are made by the customer into like the models we see the models we work with and the ones we know. Well, let's draw something in the middle that like connects the two together like this, like that intersects the two together like this. And this is where we have analysis models, which is used in requirements analysis. Okay? I mean, you can pretty much like see this identical diagram in Jasper's notes. So like you can look at that as well. But this is pretty much where we are in terms of like from the like customer side to our like engineering side of things. So a couple of things when we are creating the analysis model, it is that you have to focus on the requirements that are visible within the business domain, or basically basically you have to make sure that like these models focus on the requirements that we are pretty much working with, um, and you shouldn't go off topic. I think that's what it meant. So when we model, we want to make sure that each element of the model does like pretty much like adds value to pretty much adds to like what's our understanding of the system's requirements. Then another thing you may want to I think you may want to know is that at this point in time we don't really need to think about the non-functional the non-functional stuff and the infrastructure yet. We're gonna do that like during the design stage. Some other important things are and when we model the system, we need to minimize coupling. So make sure so throughout the system, make sure like dependencies don't go too crazy. You also have to be certain that the model the models provide value to all the stakeholders, so the stakeholders know can understand can know that we know what we're doing. And finally, just keep the model simple. Don't over engineer the entire thing. Okay? Don't go crazy. Don't go too crazy. Basically. All right. So let's get into now the domain analysis part um the domain analysis part of the requirements analysis. And also, I forgot to mute my notifications, so please excuse me. Okay. So basically, when we do domain analysis, we basically let me just write this down, and I'm gonna scroll down now. So when we do domain analysis, we pretty much turn what we know within we turn what we know about the software's domain, like basically the industry, the business the software resides in, and so on and so forth. So basically, we gotta turn what we know into some models. Okay. Well, we're gonna take a look at the analysis models in a little bit, but basically, the domain analysis helps turning what we know about the software's domain into the models that we're about to discuss. And this is where we are right now. And there are a couple of inputs that you may use to go into the domain analysis. That includes like technical literature. Let me write some things down. So it could be literature. It could be like existing applications. It could be like also expert advice and so on and so forth. Now, when now in the process of domain analysis, we will come up with some like reusable solutions, like or reusable standards. I'm going to need to like pull this a bit further. So we can come up with some patterns, for example, like design patterns that we see today. We domain analysis allow like helps us see what patterns or what's reusable solutions or what uh we are going uh basically guidelines we can use to do the modeling. So that means we may have some functional models as well, and then we and there are also other ones. You can also look at like uh, Jasper's notes for that. I'm going to just like write this one, analysis patterns. So that is pretty much what we're doing here. Now, in our lectures, we have four types of analysis models. Come on. Just making sure everything's recording. Okay, so there are four types of analysis models. So I'm going to draw a mind map here. Give me a moment. Okay, so the first one we have is the scenario models. So these deal with the high level ideas from the user's perspective. Basically, we have the functional. We basically turn the functional requirements into a model. Like, and we're gonna model based on like what's the user sees and what the user does. So what are some examples? Well, we have dealt with scenario based models before, and that would be use cases, basically use case diagrams, for example. And we may also have something called user stories. Basically, if you've seen something like GitHub issues, like you may see something you may see them in the form of like GitHub issues. Like we have GitHub issues, we have, if you've worked with Jira before, we literally have something called a Jira story, where we record those issues. Basically, things that users are telling us that will be important when we work with when we're trying to come up with the application. Use cases are like what's the user is allowed to do to the system, and that's about it. Um, so those are some examples of scenario-based models. Another one we have is the flow models. So the flow models will focus pretty much on like information flow. So you may deal with data and control flow. I mean, I know like and control flow pretty much might remind you of Mech 511, which also gives me a bit of PTSD, but this also pretty much applies. So we are we are here. We are dealing with the flow of information. So not fluids. We're dealing with information here. So we have some examples for flow models. We have the data flow diagrams, or DFDs for short. We also have data models. Basically, this is where we deal with like what is being sent over, or what is between you and the system, or perhaps any other thing that happens that interacts with the system. The third thing we also dealt with is the behavioral models. So for the behavioral models, we deal with how external events change the system. Okay, so we have a couple of examples here, and those two are we have already encountered these two. One is called the state diagram, which we will cover in this tutorial, and the other is something we have dealt with in courses such as COE 528. Basically that is like object oriented design. And in this semester we have also dealt with this in COE 692, which is the sequence diagram. So so both of these diagrams deal with the behavior of the system when it encounters like an event or a signal. Finally, we have the class models. CLASS. And the class models deal with like the static view of the system and the relationships between its parts. So pretty much, if we're gonna deal with like object-oriented programming, the class models will help you out on what you need to make in your program. So we already have dealt with some class models before. One is of course the class diagram. At this point, you should know what that is. And finally, there's one which we haven't really looked into, and it's called the collaboration diagram. Feel free to look this up on Google because this is not really covered in this course. Okay? Oh, and feel free to leave in the chat if you know what the collaboration diagram is. Okay? I'll be waiting. Okay, let me just put this entire thing down. Okay, so that's like a mind map of all the types of analysis models that we have seen in this semester. Okay, so um, I'm going to move on now. If you have any questions, feel free to ask me like in the chat, or you can also vocalize using the mic as well. And with that, I'm going to move on now with the approaches to modeling these things. So modeling approaches. So, what are we doing in this area? There are two types of approaches we have for modeling. One is object-oriented. So, in the object-oriented approach, we see a whole lot of things as objects, and it's a pretty easy approach to relate to because oftentimes we see many things as objects, like this cup and water. And the water inside the cup. So for um, the object-oriented approach, we have we use these diagrams. We can use the functional. We may deal with the functional modeling. So the functional model pretty much deals with use cases and scenarios. Then we have some analysis models. I'm not sure if that is what's supposed to be called, but I'm gonna roll with it. So the analysis models, we will make like class and objects diagrams with these. Then we may also have the dynamic models, which deal with responses to events, for example. Excuse me. So in our case, we will use state machines and sequence diagrams like as examples. Okay. But what about um what about structural? So structural uh the structural approach deals with your entire system in terms of processes. So basically the steps within your system. So we're going to have so we have the essential modeling, the essential models. So this is like a must see, the must sees of the system. And you can split it off. You can split it off into like two models. Environmental model. So this one, environmental model, deals with the boundary of the system and interactions between the system and the outside world. You may have something like a statement of purpose, just like how if you apply to a master's, if you want to apply to for a master's program, you will need to make a statement of objectives. This is pretty similar, except there's a format for this thing. Uh, some other ones you might see in an environmental model would be context diagrams. Uh, must sees. Must sees. Okay, maybe I'm going to write out like basically a must see is like what you must do. So here we have like what the system must do. Okay? Yeah. Yeah. Apparently like this kind of wording is a bit confusing, so I'll make sure like to clarify that. So basically, the essential model deals with what the system must do. Okay, so that's why I call it a must see, because we must see this in the system. Okay, yeah. So we have the context diagram, like coming from where we left off. We will also have the events list as well, which lists out like what's the system will encounter. Another model we will split off from the essential model is the behavioral model. Here comes the word behavioral again. And here we're going to describe the internal behavior. Oh, here we go. The internal behavior and data entities. We basically you may have heard of the word entities before. Um, and what this model deals with would be the functional requirements within this approach. And you may use like you may use different you may use things like a data dictionary. You may also use like a data flow diagram. You may also have like a process specification. Like basically that describes what the process is doing as clearly as possible. And we will also have the states transition diagram, which is also the states diagram. I'm not sure why we added the transition here, but yeah, you can actually use a state diagram to model the behavioral part of the essential model. Okay, So now, so we have dealt with like what's the essential model pretty much splits off into. So we will take a look at another thing within the structural approach, and that is the implementation approach. There's also one more that I have to cover a little bit, but implementation deals with like hardware. Basically, it maps the functional requirements, which I will write it as functional rec, to basically hardware and software. Okay, and what came to mind when I read about this is something something like the component and deployments diagrams. Yeah, this is kind of like modeling the implementation of the approach. You may use, for example, like a Kubernetes container to deploy a small part of our overall API, for example. So that is like modeling the implementation of our system. Well, at least a part of it anyway. Now, one more approach before we go is oh, actually no, there's only one more. Okay, this one's the last one. So in terms of the order in which we deal with these things, I'm going to copy this as soon as I can. So here, I'm gonna show you a diagram coming from Jasper's notes, which I thank you for it, Jasper. This is like the timing of like the models you're gonna work with. At first, you would deal with the environmental model because you're gonna turn like the word of mouth into like stuff you're gonna work with. Then you're gonna deal with the behavioral model. Basically, we will start working on like what data are we passing back and forth, and what the system is gonna do. And finally, the implementation model is like how we are gonna realize the system. Okay. Uh, so I'm going to get a bit into detail of the statements of the like environmental models now. Let me see if I can let me see if I can at least like get this part like out of the way as soon as we can, but like I don't want to like rush, so we might go a little over time. Who knows? The first one we have is like the statements of purpose. Like I said, we pretty much have basically this is just words. Like it's just plain English. Um, and I'm going to like paste a I'm not sure if like a a statement of purpose that I made, which I have no idea why it can't be this larger, but that's okay. Let's see if I can. I'm gonna zoom in here. So here's one where you can here's one example. Basically, we use make sure that this is clear and concise. I'm not sure if this is even clear or concise, but like we can actually work on it. And we will also this is actually for people not directly involved in making the system. So for example, like let's see, not directly involved. Like this. So for example, like you may have like top level management, like top level managers, some middle managers maybe, and you and maybe you may have some user management departments as well. That's deal with feedback from users. Who knows? So that's the statement of purpose. Um, yeah, if you all have a feedback, if you all have some feedback as to as to how like we can improve the statements of purpose, um, please feel free to let me know. I might as well just like correct it. So do note that typically we start off the statement of purpose with the purpose of something something is the purpose of something is, and then we will add more to like what we mean by that. Okay. All right. I'm gonna move on to the next model. But if you all want to like take pictures of my like potentially weirdly worded statements of purpose, just go ahead and take the snapshot now. Okay. All right. Moving on. So I'm going to now work with the second thing in the model, and that is called the context diagram. So for the context diagram, we deal with the data flows between the system and like many and like between the system and entities and data stores. Okay. So there are multiple ways you can express this, but they typically contain the following things. So first, we will have the name of the process or the system right in the middle. I'm gonna use a circle because I'm using the Jordan DeMarco uh, version. So I'm going to name my process, for example, library library management system. Like, yeah, the circle can be like a system or a process depending on like what you're modeling there. And I'm going to draw something called a terminator, which is basically, excuse me a moment, let me just get rid of the um, wire here. So the terminator would be like the entities that interact with the system or process. For example, we might have a user that's basically a registered user, and it's going to send over a search request to search for books. Okay. The and another thing you may and maybe the system itself will give the user a list of books. Okay. Another thing you might see uh is like you should also see that like I made some arrows. These arrows are called data flows. Okay, we're actually describing what info gets transmitted between our terminators and our system in this diagram right now. There's also one more that you can transmit data to, and that is called a data store. Basically, stuff that stores all of our apps important data. So in our case, like I'm going to write a classic example from COE 692, and that's the book database. And the book database can send the list of books to the system for processing. And and moreover, you may also have, I'm gonna add one more example, an admin that sends a new book entry, like a new book entry, basically a new book, and the system may send in new books to storage, to the storage. Okay, so there's quite a, yeah. So there are different So I'm going to like draw some. I'm going to write down the parts of the I'm gonna write down the parts of the diagram now. So we have entities that interact with the system. We also have a data store that deals with basically objects that contain our data. Let me see if that's right. Yeah, objects that hold system data such as files and tables. And finally, we of course the center guy of the stage is your system. Okay? So this is like where you're like basically this is where everything takes place, and I'm not gonna you don't even need a definition for this. Okay? So I'm gonna move on now from the context diagram. There are different like there are a couple of steps of as to like how you can like create your context diagram. Here we know we should first list all the activities. Basically, for example, the user can look up books, maybe borrow books. The system admin can like make a like can add new books into the system, uh, and so on and so forth. And then we will draw a system as a single bubble for now, and then identify the terminators, which in our case, it would be the people that interact with it, and finally, we will recognize the external data stores that we need in order to hold data that we need later. Okay, so that is the context diagram. The next thing we're gonna deal with is the what's this? The events list. So I'm not gonna talk too much about that one, but the events list pretty much allows you to record the events that the events that the system will encounter. Basically, this would be like uh recording all of the stimuli that's come from the outside world. The stimuli is like stimulus, but in plural, by the way. So this is gonna so you can record all of this in a table like this. For example, you may have a student that sends in course details, and like the response to this event would be like the system sending the student back a confirmation or rejection letter. You may also have uh something that occurs like at some point in time, and that is also known as a temporal event. The previous one I was talking about is flow oriented. So that is pretty much uh the types of events you'll see on an events list. One thing you need to note is that there is also a thing called the event-related flows, and basically those are like workflows that are triggered by external events. So, as an example, if you have two events that occur one and after another without any long pauses, then in that case you don't need to record the second event because that is considered an ERF or event related flow. Okay, so that is the events list. Okay, finally, oh, actually, we're done with the environmental model. We will also go through with the behavioral model. So the behavioral model, the in the first behavioral models, I've already told you about the definition. So let's go through the examples of the behavioral model. We first have the data flow diagram that basically shows like where the information is going in terms of your in terms of like processes. The processes are of course step-by-step instructions. Just like okay, no, never mind, because I was thinking about COE 628, but the process in a operating system is not exactly the same as the process in this course. So do keep that in mind. But they share some similarities. So in that case, we have, for example, I'm going to use a library management system again, and I'm going to draw something called an external agent, basically an entity that is external to the system, like a user, like before. And then I'm going to send in a trigger. I'm going to send in a data flow that is triggered by a search request. So the word search request is the trigger, but the arrow is the data flow. So the search request will be transmitted over to the process of search books. The process here is called search books because, well, we're searching for books here. And then this process can send back data regarding the results of the query. So I'm going to write book list, and that's it. Now, but where does the list of books come from? Well, we need some data stores that will help give that will help fetch the books for us. So in that case, the data store we might have would be the book DB, for example. Or you can just simply say books. And this will be fed into the process, like so. Okay? Now, a couple of rules. One, a couple of rules regarding this diagram. One, you should not have you should have both inputs and outputs. So you can't have like solely inputs and no output or the other way around. And two, you cannot have so basically you must have at least one input and output. So let me do that. Okay. Two, um, you cannot like connect two data stores together. You can also say two or more, but I'm just gonna say two. And let's see. And finally, the same thing goes for entities. So you cannot connect entities together. Okay. There are also a couple of rules especially if you want to do branching. Um, basically, you can have like there are some things regarding like branching. Um, that you can look through Jasper's notes, but one thing to make sure, does rule one apply to data store specifically? No, that applies to processes. Okay, so that applies to a process. Oh yeah, thanks for clarifying that, Joshua. Okay, so I don't think there's anything else I can like um deal with. Oh, one more thing. You cannot connect an entity and data store together. Okay, like you can connect an entity to a process, then a process to a data store, but you cannot just directly make the connection between the two. That's a pretty bad idea. It's like you're asking for the user to hack your database. A really bad idea. Okay. If you have any more rules you want to propose, do let me know on that. But like you can look at Jasper Cruz's notes in order to get yourself acquainted with the rules. There are more. But those are pretty much the general rules. Now, how do we get the data flow diagram from the context diagram? Well, basically, well, you break down like your system into multiple processes, like so. I'm going to delete that number two here. So you basically can break down from a context diagram to a data flow diagram by splitting up the system into multiple processes, and then you can further break down the processes into sub processes. Okay. That's about it. Okay, moving on, and we kind of have to be a bit quicker on that. Um, another thing we have to deal with is another thing you may see is the process specification. Um, so we use process specification to describe like what each process is supposed to do, and there are multiple ways you can express your you can express your uh, process specification. For example, in our case, we have dealt with the following. We have the logical specification. Oh, actually, yeah, there are two types. One is logical, which deals with like ideal technologies only, and there's no like implementation. So it's purely theoretical, and like a whole lot of thing. The technology is like idealized, perfect, basically. And of course, there's also the more realistic version called the physical specification. If that is the right name for it. Let me see. Yeah, it's called a physical model. Okay, never mind. Yeah, so we have the logical model and the physical model. So basically, for the physical model, you add implementation details to it. Basically, you're gonna add some assumptions regarding implementation. Okay. Now, there are three ways you can do this. Uh, one is called a one you just use structured English. Basically, you use your language without the swear words. And you have to make sure that you add like the structured pro you add like a bit of like programming words into your into your like structured English to into your description basically. So I have an example from Jasper right here we can look at. Basically, it's like, for example, if you want to record customer information, like if you want to describe the process record customer information, you first ask if the customer has an account, and then if the customer has an account, you ask for you ask for like authentication and all that, and so on and so forth. I'll leave that to you to read. This is also available on Jasper's notes. I will post the links to those notes like after this tutorial. I'm not sure if we're gonna need to extend the tutorial by 1 hour. Hopefully not. Um, okay. Another way we can do this is we can use the decision table. The decision table like basically it lists out like the combinations of your inputs, and from there you're gonna compute the output. It's like a truth table, but instead of just like truths and falses, we're going to have different ranges of inputs or different types of inputs. But it is similar to a truth table for sure. And finally, we have the tree version of the decision table, and that is called the decision tree. Basically, we just turned our a table into a tree, and and the tree will show us like different paths we can walk. Okay? Okay. Any questions? Okay. Wow. My notes are getting a little bit long here. Um okay. Let me take a look at some more models. Oh, let me see. Okay. So we got data flow diagram and all that stuff. Okay. So now I'm going to talk briefly about like other modeling things that we will need to do, and that means scrolling all the way up. So let's go ahead and talk about state machine diagrams, or maybe state transition diagrams. Okay, so for the state machine diagrams, we basically describe the behavior of a system graphically, and we split the system into different states. You can think of the state as a group of attributes, or basically like a class of a class of behaviors and properties and so on. Like if I'm in a drinking state, I would be drinking water. So one thing you can do with state machine diagrams is you can model objects that respond to the same events differently, depending on depending on like what it is currently doing. In our case, we just call that the current state. So to keep this short, what you do is that I'm gonna copy and paste the diagram here, but I can also draw it out. Basically, you have like the dot as the start state, and then you have like the typical state. The start state is basically like the starting point of the machine, and that's when it gets created or when it gets started. Or most likely, this covers when the machine is created. In our case, before when the machine is created, we turned it off. The arrow here is what we call a transition. Basically, it's when an event occurs in the machine, we move from one state to another. So that's what's called a transition. This arrow tells us what transitions can be done. You may also have something like a trigger. Let me see if that is correct. Um, let's see. Is it called a trigger? Okay. Yes. We have the trigger. And we also have something called a guard. So the trigger is like the event that occurs to to make the transition happen. But the guard is like the condition when the trigger happened. That's the system needs to that needs to be fulfilled in order for the transition to get the go ahead. And finally, next to the slash here is called the effect. Basically, what we're gonna do when the transition happens. Okay. By the way, inside the state, you may also have like events inside the state as well. And let me see if there is if there is like a description of the thing. I don't think so, but that's okay. So basically we have the on state, for example, and the on state might have like descriptions as to what it's doing. Like there are like there are four triggers. There are four actions. There are four triggers. The state can uh, use to do actions. For example, in our case, we got the on entry. We have the on entry. We have the do. We have the on event and on exit. Okay. So entry means like if when the system goes to the state, like enters the state. Do is do happen the do trigger happens like while the system is in the state. the on event trigger happens. Let me go ahead and bring that up. The on event trigger happens when uh okay. Okay, so it's also known as a deferrable trigger apparently. Um basically basically it is when the event is ready for processing, I think. Yep. So basically this runs when the event is ready for processing, like before the processing actually happens, of course. And then the exit, and then finally the on exit happens while when your state exits, when your machine exits a state. You may also have you may also have something like a and what is it called, the final state. For example, if I were to like if I were to like Apple, so if I have to like Apple, if I have to like draw something like the life of an apple, like it suddenly appeared in a basket, like for example, like if you're making a game, uh when it happens, like it's gonna be idle, like it does nothing, and then uh and then it is picked up. So if it's picked, then it's going to be in the picked up state, and then if it gets bitten, it will be in the eaten state, and finally, once it's gone, well, it's gone. So this part here is called the final state. That's the end goal of the object, and therefore the end of its life. Okay? You can actually add a description to the like initial state, by the way, like the start state. But make sure that you only have one. Okay? The objects can be only created once. But you can have multiple final states, and you can even have zero as well. Okay, I'm gonna skip over a couple of these. You may also see something like substates and a history state. You may also even have like concurrent regions as well. Feel free to look at Jasper's notes for that. So I'm going to like write down substates. For example, you may have something like running, and inside running, you may have like you may have a idle state and so on. Okay? That's a substate. Uh Another thing you have is a history state. The history state remembers the state that comes before that the states that the submachine perhaps is in. Let me go ahead and scroll down. So the history state, it okay. The history state remembers the state its machine is in before um before the machine itself gets like interrupted, like it gets shut down, for example. I'm gonna do this. Okay, and also my placement is a little weird here, so I'm going to move that over. So that's the history state. Basically, it remembers, and when that and when the machine has maybe jumped a maybe when the breaker jumps and the machine like suddenly lost power, we can turn it on again and the machine will still go back to what it was doing. Okay? And finally, we will have concurrent regions. That is when like two states are being like basically a even a machine can have two states that run in parallel. So a machine can be in in multiple states at once. But it could be, for example, if you're applying a brake, your front of the car will apply the front brakes. At the same time, your rear end of the car is gonna apply its rear brakes. Okay, next up, ER diagrams. Um, so let me. So next up, ER diagrams. I mean, okay, sorry, my speech is like getting a bit crazier here. I am I'm a little bit short on time here. So entity relationship diagrams. We have seen this diagram in CPS 510. So this is so I'm gonna write that down. So basically, you have an entity. Basically, you may have a database that stores the following data. You may have something like an entity, which is in light blue, and some a relationship with a name on it normally in the diamond, and the circles and the ovals are denote attributes. Sometimes you also see attributes in white. Well, not in white. Attributes in underlined. Let's see if I can get some of that. Oh, never mind. Okay, I'm not gonna do that here because because those do not deserve to be keys. But normally you should have you should have a key like basically this ID, and then you add a underline here. So if you see an underline on one of the attributes, that's a key attribute. Basically, it is what uniquely recognizes a record of the customer, for example. Okay. You may also um, you may also see something related to the cardinality and modality of the relationship, which I will copy and paste some stuff about it now. So there are two ways you can denote like the types of relationships, basically the constraints of the relationships here. There is the crow's foot notation, and then there's also the min-max notation. So these denotes like the cardinality and modality of the relationship. So feel free to give these a read, but this is CPS 510. Except for the crow's foot notation, because that's pretty new, and it was also mentioned in a COE 692. Okay. I encourage you to review on CPS 510 or any like entity relationship diagram related stuff in here, because I'm not gonna talk too much about it. But yeah, feel free to look into this more. Okay. So, I'm going to do some scrolling, do some scrolling, do some scrolling. Okay. So now that we have dealt with requirements analysis, which took quite a long time, I'm now going to briefly talk about the requirement specifications and how you can like do stuff with that. So the next thing we're gonna do is requirement specification. Okay. So I'm going to scroll here. Okay. So requirement specification, this comes like after requirements analysis. So so I'm gonna write that down. So first we have elicitation, then we have analysis, and finally we have specification. And right now we are here. Okay. So the software requirements specification, there is basically you can use a software requirements specification document in order to get what you need in order to like document in order to do the specification. So the software requirement specification document is also known as the SRS document. And there is actually a template made by IEEE. Uh, and what it does is this is like a reference to the dev team. Basically, if we're gonna be in the dev team, this you will see something like that. Uh, it will also uh, ensure that that we still align with the stakeholders' needs and expectations. I'm just gonna write this down as quickly as I can. Okay. And make sure and you what you can do uh, and what you can and the SRS document also helps provide it helps like it is designed to accomplish four things. First, it provides feedback to the customer. Uh, okay, so some goals to accomplish here is this provides feedback to the customer. Like basically, we're just responding to the customers here. Next is you can decompose your problem into parts. Well, components rather. Then and also you may have like this is like this can be treated as an input to design specifications like your design docs. And finally, this is like a validation check to people who are validating your product. I recommend you take a look at the IEEE 830/1998 standard. to review the stuff from the lectures. Okay. So that's the requirement specification. You just make a document, follow the template, and then voila, you're done. Okay, moving on. So requirement specification is done. It's 9:30. So another thing you might want to do is requirements management. So for requirements management, um, we are basically on the third thing in requirements engineering that we haven't covered as from the midterm session. So basically, right now we are here. Okay. So requirements management, we can split this off. We basically we are overseeing changes to requirements, and like we respond to those changes. So basically, when you deal with changing requirements, you may encounter some problems. For one, you may have a late change into the development cycle, and like you didn't even assess its impact. So you may have so basically the timing is not right. So the timing is pretty late, and when you assess its impact, uh, well, you basically maybe you even lack it as well. Like you may lack an assessment on its impacts. In that case, this will cause delays because you may have to remake your program all over again. Two, you may have outdated requirements. This will even cause confusion and unnecessary rework. Like, for example, why do we have to use let me think about this. For example, let me take a look at some examples for outdated requirements. Like for outdated requirements, it could be like the use of really old technology. Like I'm thinking of some old technologies or older frameworks on top of my head. Let me see. Uh Old API frameworks. Let me look this up. Uh okay. Why are we still using old versions of SQL Server? Why are we SQL Server, older versions of SQL Server may lack some features, but we want something that is in a later version uh implemented in maybe the old version. So that causes confusion, and that might also need some rework. So that's a weird requirement I might list out, but there are different ones as well. And changing requirements can be problematic when testing and during like like during testing and implementation. So when you test or when you're implementing it, and even during documentation. And actually, I'm going to like correct some grammar stuff here. So basically, if your implementation, testing, and documentation are all ready, like when they are already completed, this will be changes to requirements. They cause a mess. They will make us really angry. And it does give us the impression of the management does not knowing whatever the hell they're doing as well. So that can be problematic as well. Oh yeah, I mean, I would be pretty mad if like our software needs to be thrown out the window because apparently the requirements change on a whim of on the with a flick of a pen by upper management. It is a really frustrating feeling sometimes, especially when you're passionate into it. But normally I wouldn't be so passionate. But hey, it does cause a whole lot of problems if it when like changes to requirements occur like after we tested everything and documented everything. Yes, because reworks will happen too. So there are so how do we manage so what activities do we do in order to deal with requirements management? Hang on. Requirements management activities. So there are four types. We have the change control, which processes the which controls like the changes to these requirements. Maybe the changes are like too large. It will be a huge leap. In our case, we need to think of ways to make sure that we get that under control. Like we look at the impact on our products and so on. Next is the version control, which is dealing with like the version of our software, for example, like version numbers. Next is status tracking. Basically, we monitor like what how each requirements are in terms of completion. And finally, tracing, like we define links to other requirements. Another thing we kind of learned is developing and is like how we link developing and managing requirements together. Um, and we use something called a baseline document in order in order to set a reference point to track changes and manage new versions of requirements throughout the project's lifecycle. I'm going to show you like how we can like the roles of uh, I'm gonna show you like the baseline documents like how it's being handled in multiple parts of the in multiple in the sides of like requirements hang on requirements development and management. So basically we need in requirements development which is denoted as RD. Let me see if I can like, align the. Oh, okay. There you go. Oh, oh, okay. That's fine. So in uh in requirements development, we deal with the requirements set by the marketing team, the customers, the management. So we analyze these requirements, we document them, review them, and then negotiate to see if like some changes can be made to make them more reasonable. For example, uh, milestones and timelines. And these will go into the list of baseline requirements. It can be in the form of a baseline document. Then, when we manage requirements, we look at perhaps like maybe we got the same customers and marketing team changing the requirements. We go through a process. Oh, let me try this. So when the customers, marketing, and management have a change in requirements, we look at we go through a requirements change process. The same thing goes if the project environment changes as well. Like for example, we are switching from a Java backend to a C# backend. Okay, like I'm not sure. That would be a non-functional requirement, but maybe because if the project has some incompatibilities, we may also need to change its environment related requirements as well. In our case, we go through the same process. We then go to revise the baseline. Okay, we're gonna create a new version of the baseline document. And remember that there is no management without traceability and baselines that enable comparisons. Okay, so I'm going to give you a template for a baseline document that you can take a look. The baseline document does come in many shapes or forms. This is one thing you have to know is that this is read only. Once you submit it and get it approved, uh, so if you get it approved and agreed by stakeholders, this becomes read only. So you cannot change this document. You like for example, just export that into a PDF and never give access to the Google Doc that's made this document. Okay. So make sure you establish access control for that. Okay. Make sure that you avoid losing any changes by adding access control and like reviewing the history to the changes to see if there is anything new. And I'm going to show you. Wait, hang on a moment. I'm going to show you a link to a template that you can take a look at. So here is an example. Like here's a example template that you can use. We have 15 minutes. Let's see if we can like get through the fourth topic as well. Oh, there you go. And I'm going to just Uh, okay. I want to see like the link as well. Can I add text? There you go. You can add something like that, and then format the text. Can I even like okay, you know what? Never mind. I'm not gonna. You can take a look at this link. I will also share it with you in the chat. So y'all can take a look at this one. And hopefully you'll get a general idea on like what the project's baseline document would look like. It will be pretty similar, but there will be a whole lot of variations. So this is not the only one. Okay. So another thing you may want to know is like you want to know why a requirement changes, right? So why does a requirement change? So one is that you may have conflicts, errors, and inconsistencies. Basically, you may want to negotiate changes to these requirements. Um, if you found that like there are some things that are impossible to realize, or some things that are utterly unreasonable. Uh, another reason why is you may have like you're working with a evolving customer or user base. Like basically you may have like as the customers and users gain more knowledge about the system, they may realize that like there is a feature they need that we haven't even considered at all, so we change it up. And finally, we may have changing customer priorities, and ideally those changes to the priorities should not change too often unless you're working with some really terrible management. Okay, so changing customer priorities would also trigger a change in requirements as well. And of course, if you think about the waterfall model makes handling changes to requirements very difficult because the feedback goes way later into like after deployment. For agile models, well, it's actually easier because you can make multiple iterations based on customer feedback. Okay. Um, Let me see if there is anything we need to look at. Okay. I was just looking at notes made by Jasper. Um, so So basically, I would also like to let you know on like two types of requirements. One, we have the stable requirements. The stable ones relate to like the core functionality of the system, and they don't change often. And it can be split off into multiple categories. You have the mutable, emergent, consequential, and compatibility. Okay, let me scroll down now. So, mutable requirements may may change due to environmental changes. Emergent, the emergent requirements, they cannot be fully defined at the beginning of development, so they they become more defined like during development, like during like design and implementation. Okay, let me. Yeah. Oh, and by the way, if since we don't have much time left, I might extend the tutorial by like half an hour to see if we can cover risk management a little bit before we go. Well, we'll have to see. We'll have to see because my speed is known to be a bit slow this time. Okay. Are you gonna cover goal modeling? I thought I covered goal modeling like during the midterm tutorial, but I will loop back to it. I will circle back to it. Like later on once we covered risk management. Okay. So consequential. That is when that means that may be incorrect because it's based on an assumption. Like it could be based on some assumptions. This is recorded, right? Yes, it is recorded. Yeah, so if you cannot make it through like the extended hours or the extended hour or the extended half an hour, you feel free to leave at 10 like on the dot as well, because this is recorded. And finally, we have compatibility requirements. This depends on these depend on the technology and equipment we use. So it depends on the tech, equipment, and processes. So processes in place. I'm gonna write it like so. Okay. So some key expectations of requirement management. Oh, actually, I forgot to write down. There's also volatile requirements. So volatile requirements mean they change frequently. Okay. Yeah, that's about it. Some external factors could be regulations, changes in technology, or even shifting business needs. Okay, those happen, and like the requirements will be affected greatly as a result, and those are called volatile requirements. Okay, so in requirements management, some key aspects you may need include um, like identifying and documenting the individual requirements. So so I'm gonna write this down right now. So expectations. First, you have to identify and document the requirements. Like remember to do that. Like you have to do those for each individual one. The second is establish the traceability uh, from the requirements to implementation. Third, you have to conduct impact assessments of the proposed changes. This one is pretty. This one's pretty important because I we do expect requirements to change since the world is always changing. Next is you need to control access to project information so that like secrets don't get leaked out. And finally, you have to deploy required tool support in order to help manage the requirements. So those are the expectations during requirements management. Okay. Um, I'm going to skip over like all the steps in detail, but you can look at the notes for that. So I'm gonna move over to risk management and analysis, which uh which I'm gonna do on a new column. Okay. Let's see. Let me take a look at the name. Oh yeah, so it's called risk management and analysis. So at this point, at this point, I won't be able to cover risk management and analysis on time. So I will stay here for like an extra 30 minutes or so to cover this topic and answer some questions. That includes like stuff regarding goal modeling as well. Um, but first, risk management. So first, for those who are leaving at 10, you can leave now. Thank you very much for coming. Hopefully I won't have to stay for too long. Um, and yeah, this is recorded, so you can come back and watch and like watch uh my recording about the management and analysis. For those who are staying, we let's get into the risk management model. So, when we talk about risk management, here are some steps that we use. Let me see if I'm in the right place for it. Hopefully so. So we have the risk management and analysis. Here are the activities that we do in order to manage the risks of our manage the risks that are present in our project. So risk management planning, we start at the top left corner here. So this is when we conduct when we conduct like a when we define how to conduct the assessments to find out the risk of to find out the risks of our projects and how to control them. So basically, we first make a plan on how to manage these risks. Then we start identifying the risks. Then we do a qualitative risk analysis. That is prioritizing risks based on their probability and impact. We also have quantitative risks analysis. Basically, we analyze them using numbers. Uh, Risk response planning deals with how to respond to the risks when they actually come true. Risk monitoring deals with risk monitoring and control. These deal with tracking the risks uh, and monitoring what's the risks that the residual risks that come after you and they also work on identifying new risks and executing response plans and evaluating their effectiveness. So these two work together in order to make sure that we are managing the risks correctly and effectively. So the model we learned about here, we have heard of, we learned about in the lectures is called the Taylor model. Okay, so I'm going to so when we do our risk management planning, uh, let's see. When we do risk management planning, we may have oh oh there, hey, pen, come on. uh okay. So first we will deal with a bit of risk management planning. Okay, so risk management planning is when we take a look at the scope, we will be given a scope. We'll be given a scope, and maybe a cost management plan, some schedules, all these that we derived uh, when we look at when we analyze the requirements. Let me just put this down here. Okay, so we start with our given inputs. We got communications from we got the plans on how to communicate the how we handle communications, how we handle scheduling and timelines. We also are given the project scope, the cost management, and enterprise environment and processes that are in place. So some techniques we use to do planning is we host planning meetings and we also analyze the and analyze the plans. And afterwards, from the results of the meetings and analyses, we will generate a risk management plan. And yes, and of course, to remind you, project scope statement, while it might look like it's useless in there, it actually has important information for risk planning, because you might be able to pick out like some things inherent in the system that are gonna be a risk in the project. So some risk categories that some risk so to break down the risks into categories, here is a nice little map on how to break those down. So when you're over the course of the project, like you may have to evaluate the risks and put them into several categories. Like these are pretty much examples of like how you can break it down. I'm not sure if it's just an example or if it's like already all of them, but these are you might encounter like some of these like one way or another. Just make sure you put these put the risks that you identified in the right spot. So the four big categories include the technical types deal with complexity or unproven technologies and performance goals. So let me write that down. Complexity, uh, technology, and performance. Okay. The second big category here is project management risks. And these associate with improper schedule and resource planning. So we have a bad schedule. We planned. We basically we don't have a good timeline on this. Let's see. Uh, scheduling, resource planning, resource planning, poor project planning. Let me write that down. Okay, project planning and uh, basically even like bad methodologies will present a risk in the project management category. And then there is the organizational risks. So these deal with the company related conflicts, like basically so basically if you work in a really toxic company, you might receive like conflicting like unrealistic scope. So you may have like an unrealistic scope time. Like, for example, how would you even make a game in a single month? Especially if you're gonna work in an AAA studio and your bosses tell you to create a new game from scratch and like release it in a month. How the hell are you gonna do that? You don't. That's an organizational risk. It may also be something related to cost as well. Um, and and that and also funding. Maybe the company is running out of money, and And that might present a risk because that means we won't be able to have the resources we need in order to realize the project. Finally, um, we have external risks. So these are pretty much like outside of like what we outside of what we can control. So such as new laws or regulations, labor issues like people going on strike, uh, ownership changes, and also like catastrophic events, like catastrophes, as a noun. Okay, so these are like the four big categories of risks. Okay, so you can then further break them down into like different subcategories as you go. Okay, I'm gonna move on now to identification. So let me do risk identification. So for risk identification, you identify the source. Okay. You basically you want to look at we want to discover and analyze potential risks, and like we have to continue to refine our understanding of the project and like uncover more. So we continually refine understanding of the project. So that includes scope and risks. Okay, so basically, when in risk identification, we look at we look at what we have, then we document we review our documentation, uh, gather some information, and so on and so forth. We can we may also like take a look at our checklist, some milestones, look at the analyze the assumptions to see if they are viable assumptions. We may also look at some our diagrams to we have so far to see if actually no diagramming techniques we use diagrams to organize like what we our findings. We use something called a SWOT analysis, which I think it comes a little later. um, and finally, we may also find some consult some experts to look at to also look at our findings as well. And afterwards, we will get a risk register. So you may also look at like diagramming techniques and so on and so forth. Like there are different types. I'm gonna cover a bit of diagramming, but you may look more about that. So some diagrams that you may encounter here. One is called the cause and effects diagram, otherwise known as the fishbone diagram. So fishbone diagram. So basically, you may have like a so basically you have an effect at the end of a really huge arrow that you're gonna draw fish bones that deal with multiple categories of causes. So this category, for example, can be like financial, and you would then draw an arrow that points to this bone and write down the cause. Okay, so that's how you do it. So make sure you understand like the categories the causes will be in, and you just put them into a fishbone like this. Another one you might see is flowcharts. You have seen these before, and they basically document steps as to what we're gonna do in case like the risk turns out to be true, like turns out to come true. So we have a preparation symbol. So that's the start, and then the decision symbol is like the if then else of the process of the flow. The process symbol is like a step in the process, and then the termination symbol means this is the last step. Once we're done this, we are pretty much done until we have to restart the whole thing again. Okay. So that's flowcharts. Uh, and finally, we have influence diagrams. Uh, so influence diagrams, basically, these list out like these show you the relationships between different uncertainties, which will affect the thing in the middle. Like in our case, like the project scope, the cost, and like the timelines will affect the quality of the project. So this model the relationships between like those risks, certain decisions, uncertainties, and the impacts that come along with them. So it's like a mind map, but pointing inwards. Okay. So I'm going to so that is um identification. Next is analysis. So next is risk analysis, and that is so there are two types, of course. One is qualitative. So we're basically looking at impact here. So qualitative is based on it is less detailed, nor is it any more precise, and it is based on likelihood or chance. Quantitative, however, deals with it's rigorous but precise. And this type of analysis deals with a whole lot of numbers. So we deal with so it is based on statistics and numerical models. Okay, I'm going to move this down. So that's risk analysis, and then you will learn how to there's something called risk projection. And to put it simply, Risk exposure is oh my risk exposure would be equal to the probability of loss, and you may also have to define the size of the loss. So the probability of loss can go from 0 to 1, and then the size of the loss, well, you can define any number you like for that one. For example, you may want to lose you may lose time if a risk turns out to be true, turns out to come true, and so on. So basically, um, if you do you may have like a risk register, or actually you can use a probability and impact matrix in order to basically you have something like this. So I'll leave this chart for you to take a look at. This defines like what sizes of loss you may use. And then you can use like a probability and impact matrix. Which I will leave an example here. So this is here to organize your probabilities of loss. And actually, yeah, I think that's it. Yeah. Okay. Actually, I think that's what it is. But let me take a look. Um, okay. So the probability and impact matrix, basically you assign an overall rating to each risk. Uh, by using the matrix like shown here. So these are used for like prioritization. Okay. Um, what you will get here, if you use like if you use quantitative whenever no matter what you use, you will be able to update your registers. So what you're working with there will depend on like the method of analysis you're gonna use. In our case, this one is the top one here is quantitative. The bottom is qualitative. And you should update your risk registers accordingly. Okay? All right. So, that's it. Honestly, that took more time than I thought. I am so sorry. As for the other parts of of the risk management steps, feel free to look more into it. So I'm gonna write this down. Feel free to look more into risk management activities. And I'll stay here now for questions, but before that, I want to stop my recording. Oh,
Recording stopped.
okay. I will also stop recording OBS. So say goodbye to OBS. And yeah, thank you so much, everybody. Have a good night and good luck tomorrow. See you at 10 or earlier.